Okay, welcome to the pet store. I know I'm not the TA anymore, but I hope that if you learned from watching this video that you will be interested in playing my game. We desperately need more playtesters, and we'd be so excited to have you join us. At the end of the video, there's going to be a short clip of what the gameplay looks like, so if that interests you at all, please, it would mean a lot. We're going to be implementing a pet store, which is very similar to what you guys are doing, but it is not the same. So do pay attention, and also it might give you hints in what I can only assume would be your next assignment. So first of all, we have just a generic C# script. It has the new formatting, but if it didn't, then really you just see void main here. No difference. And you can see that by default when I press play, we get our game. It just says hello. So the concept in the assignment given to you is called composition. And the idea is you're taking a bunch of objects and you're putting them together. In Unity, everything is a game object. So in your hierarchy, everything is a game object. Every game object is composed of a bunch of different components. One that is always there is a transform. Every game object has a transform. And you can have other components like a rigid body or a collider or your player script. And those are all components. And they're all scripts. So we would just add a new file for that. There is one key thing here. The word have. When you hear have, I want you to think, okay, variable, immediately. If I'm saying we have a transform, you're thinking, okay, we have something, and we want to be able to say transform, like that. This would mean you have a transform. And if we're able to say that a transform has something, then that would mean that inside the transform script, it would have like a vector3 called, position, for instance. You can decompile the scripts in Unity and take a look at them yourself. We're not going to do that today. So to start, we have our main file, but we're going to actually create a new file that's going to be called our pet store. So I'm going to right click here, add a class. It's just going to be a pet store. And I'm going to do another. This time it is going to be a pet. We're going to go a little bit above and beyond as well. I want to have different types of pets, and you can choose to, we're going to add them right now actually. You can choose if you want to create it as a new class, or you can put it directly in. So I'm going to do it for both. We're going to have dogs and cats. I'm going to say dog, and then in the actual pet store class, I can also create it in here if I wanted to. Public class cat. Or I could create it here. And it's really like artistic how you want to do it. For the sake of small projects, and I like having smaller files, I'm going to do it like this. So we have dog, cat, and pet. And I know I said that backwards, but don't worry about it. Okay. And we have our pet store. Everything's just blank. Now, to start, ask yourself, what are things that your pet store would have, and what are things that your pet store can do? Well, to start, our pet store needs to have an animal, right? So we'll have our pet, that is our animal. And then maybe we want a way to see what pets we have. So let's have a public function, because we want it to be accessed everywhere. Public void check pet store. Okay, and we can return a string, or we can just do whatever we need to do in here. Console.writeLine to output a message into our console. And let us get our animals. So what we can do is we can say type of animal, or is it animal.getType? There you go, animal.getType. And we can check our pet store this way. So our pet store has an animal, and it can be checked, so we can see what's in it. Let's go back to our driver file, our main file, and let us actually create a pet store. So we're going to say pet store, and then my store. And then what I want to do is we need to actually create it. So if we just left it like this, it would be null. So we need to say equals new pet store. And we've built it. This is a constructor call, and the new keyword is very important, as I emphasized last semester. It's just very, very different in Unity. You're unlikely to use it in Unity. But you should know that it's how we create objects. So we've created a pet store object. And then what I want to do is I can now say my store.check pet store. And again, if you're not using Writer, because you're using Visual Studio for some reason, it's free. Use Writer. Don't don't make yourself suffer. Anyways, now when I press play, so we get an error. It says the object is not set to a reference. And that's because in pet store, animal is null. We need to say equals new pet. And now we've constructed our object. And there you go. The pet store dot pet is the type. It's a pet. It belongs to the pet store object. This is pretty lame, to be honest with you. We want to be able to do more. And also, what is a pet? So before I continue talking about composition, I want to talk a bit about polymorphism and inheritance, which are two really, really important concepts, and I would not be surprised if this is about to happen to you guys. So what we're going to do, let's head over to pet, and we're going to make it an abstract class, because what is a pet? Anything could be a pet. I could have a parrot. That's a pet, isn't it? I could have a spider and say it's a pet. It's up to you. It's interpretive. What's an animal? We have a dog, right? So in an abstract class, we are not able to create an object of a pet. That's not allowed. However, we are allowed to create children of it that are not abstract. So in dog, we're going to extend, sorry, that's Java. We're going to extend pet, and in cat, we're going to extend a pet. And what this means is a cat is a pet, and a dog is a pet. So when you hear the words is a, you're thinking, okay, it's a child-parent relationship. And what this means is everything that a pet has and can do, a dog and a cat have and can do as well. Let's start. Hopefully by now you know private, protected, and public. We're going to start by creating a name because we want to be able to name all of our dogs. But we don't want things to be able to change their names. Only the pet should be able to do that, the main file. So we're going to say private string, because it's a word, name. Okay? And sorry, that is, it would be this is best convention, I believe. It really depends. I've been working in Unreal, and in Unreal, the best convention is this. It doesn't really matter, honestly. Now, let's define a constructor. So to define a constructor, public, because it needs to be accessed in another file, the name of the class, circles, squiggles, and then your parameters. We want to be able to take a name, right? So we can be built. So string name, and let's assign our value. Okay. Now let's head over to the pet store, and we can build an animal. So let's actually fix our errors first. We need to override our constructor, and we need to take in a name. And Rider will do this automatically for you. Yeah, pretty straightforward. You can also, no, this is just how you do it in C#. C++ is different, but there you go. In C++. It is different a little bit in C++, but that works the same in C++. Sorry, Java. Normally when I'm doing stuff like this, it is in Java. Okay, so we come back here. We can no longer create a pet because our pet is abstract. It does not exist. Instead, we can create like a cat. And our cat needs a name, Jeff. Okay, and then we want to be able to print our name. Now I have a question for you. If you got a pet, name is private, right? So if in pet store, I can't just say pet.name, but also name is inside of pet, not cat. So will this work? Let's find out. So we're going to create a helper function. This is very, very common practice. We're going to say public string get name like this, and all we're going to do is return name. And if you recall from our last semester, you might have seen me doing this before. And then we do like this. And this is just the C# way of writing fancy things. You could, oh, it's not working because I already have something called getName. I'm like, why is that not working? Fancy C# way of writing things, it does not make a difference. You could even do get private set and make this public, which is also what we did in Unity sometimes. All different ways of doing the exact same thing. We're just going to keep it like this. So we have our private name, our public get name, and let's access it in here. And hopefully we see that our cat named Jeff will show up. There you go, Jeff. Fantastic. So now we have a means to create new animals. And also notice how our animal, cat, is just a pet, which is generic. So this is called polymorphism. It means of many shapes. Because a cat rather is a pet, that means that you can create a pet as a cat. Now, we have gone up a layer here, which means that if I was to add a function in cat, public void, and then, I don't know, maybe a cat can jump. So a cat can being a function jump. And then in here, I want to say animal dot and jump is not an option because I don't know that it is a cat. But what I do know is it's an animal. So anything an animal can do, I can do. But if I redefine this as a cat, then I can use it like a cat. Another option is I could cast it. So if I cast this as a cat, which will work because it is a cat, and then I can jump. And in jump, let's just print console.writeLine jump, just like this. There you go. So I have Jeff, and it says jump because I casted it, and it is a cat, right, as we have determined. So that works. But if I was to create this as a dog, it doesn't work because it is not a dog. It is a cat. Another thing we could do is called a safe cast, and this is a C# thing. If I said as a dog, or rather as a cat, right? And then you can see that it wants conditional access. If you are a cat, then you should be able to jump, and if you are not, then you shouldn't. Bit of C# witchcraft that you can do. I wouldn't get too comfortable with this unless you plan on being an exclusive C# developer. Okay, now that we've talked about our foundation, and really this whole project is just what we've talked about. So if there's something that's confusing up to this point, you can keep watching or maybe watch this part again. At this point, we need to start implementing a bunch of things. We have to design a class structure, which really means just a bunch of things that our pet store is going to do. And then we also need to implement methods to add, enroll, and we need courses, is what this says as well. So maybe we need like a kennel script so we can move specific animals into a kennel. First of all, let's just make a function to add new animal. And in here, pet animal. And then to be able to add an animal, well, we're going to need a type of data structure. So it could be an array, could be a list, a stack, a queue, dictionary, a set. These are terms that if you're not comfortable with, you can reach out to me and I'll explain them more. Or maybe I'll make a video if enough people request. But pretty much they're ways that we store data. In this case, we want a list. And we want a list because we need to be able to add and remove to it. And we want to be able to lazily check and see where things are. Just check it, right? So we're going to have a list of pets that are called my pets or store pets. And we're going to create a new list of pets. There we go. And then we can build a constructor for our pet store. Just so you know, when you do this equals new pet, this is actually secretly put into your constructor. It's hidden, but it doesn't really matter. I'm going to do this. Okay, I'm going to delete this original animal. Actually, let's not, just so you can see how this works. Then I'm going to say storepets.add, and let's add two. First of all, I'm going to add the animal. And secondly, I'm going to add a new dog named Tim. Okay, that's great. And then in add new animal, let's also have a remove function. And these are just helper functions, especially because this is private. So it just allows us to like force things to be correct. Public void, and then remove animal. Okay, and maybe you want to be able to remove animal by name, maybe ID. It's totally up to you. So maybe we do one by ID, remove animal into ID, which is the most optimized because we're using a list. So we'll say remove at ID, which is instant. But maybe we want another way of doing this. So I'm going to say remove animal again, exact same function. And this is called overloading. It's when you have two functions with the exact same name, but their definitions are different. This time, we're going to check for our animal. Now, you could make this into a dictionary and store all their names like that. We're not going to do that. Probably if you were doing with students. Actually, you know what? Let us do that. So we're going to create a dictionary instead of a list. So that way the lookup time is instant. But then this makes no sense. No, you look up a dictionary, or maybe you know how to use it already, but I'm not going to do a dictionary right now. So in here, what we should do is we need to check if, oh wait, I'm in the wrong spot. Over here. we need to check for each animal, right? In our for each store pet, and it is a pet. So for each of our pets, we need to be checking if the ID dot equals store pets, and dot equals for string store pets, sorry, dot name, which I believe is supposed to be better for store pets dot get store pet. I'm stupid. Sorry, we're in a for each loop. Pet dot get name. There we go. If this is true, then we should return, and we should also remove the animal. But maybe we want to actually return the animal that is being removed. So we can say return pet up here, and we can just remove it from our queue. So we're going to say store pets dot remove, and then we have our pet. The for each loop might actually complain about this, but remove returns a boolean and only returns true or false, so we're going to need to store it beforehand. So pet, my pet equals pet, remove, great. Maybe instead of a for each loop, because we don't want to iterate through this twice, let's actually do a for int loop, for I loop. And then let's delete this. And then upper is going to be pets, store pets dot length. Okay, so for each of our pets, we're going to create a temporary local variable so we can cache it. We're going to call it pure pet equals store pets at the index of I. And there we go. Remove at I. Or instead of this even, we can actually just say return remove animal, and then our ID, which our ID is going to be I. And then over here, return null. Okay, and then in here, we need to change this to be a pet. And we're going to return, whoops, not over there, that's illegal, store pets dot, we need to cache it, pet p equals store pets at the index of ID, return p. There we go. Cool, so now we have two different ways to remove an animal with overloading. So there's two different implementations of this. And then there's also adding a new animal. So let's do adding a new animal, which is really straightforward. Store pets dot add animal. That's it. Let's delete Jeff. I don't want it anymore. New cat. Jeff. This one's Jeff. Animal. There we go. Okay. What else do we need to do? We need a function. Let's make a function that will separate them. And really from here, it's just a matter of playing with things. So we have removing animals, and we have adding new animals. We have checking our pet store. What we should do is whenever this function is called, let's go through all of the animals that we have, and let's just say what we have. So we're going to do for each, and store pets, for each pet, p in store pets, for each pet. Let's say over here, console.writeLine. Let's do like this. And we could do slash, no, we don't need an extra space. Active pets. And then in here, console.writeLine. And let's add also two counters. Let's say int dog count and int cat count. Set them both at 0. Okay, and then what we're going to do is if p is a, or, yeah, if p as dog, then dog count plus equals, or it just is, if p is dog plus equals 1. And this is a bit of C# witchcraft again, but it works. And if we are a cat, then the cat count increases by 1. You could also directly check the type, but this is just automated C# stuff that you should take advantage of because you can. So if it's a dog or a cat, we will increase their respective counts. And then what we're going to do, let us actually space this out a little bit nicer. Let us have a string here, str, and we're going to say over here, dog, like this, and over here it's going to be cat, and then we're going to print, so console.writeLine, str, and then we need to concatenate, give it a default of null. If it's not a dog, then we should actually put an else if here, because it can't be both a dog and a cat. Oops, where are we? I closed it like a stupid boy. But we have both of these. Okay, and then we need to give it a default fill, so that way it's not complaining with us anymore. Here we go, str equals. And then what we should do is let's get the animal's name. So we're going to say p.getName. Okay, and then at the end, let's finally print our totals. Total pets. Okay, and I'm going to show you a bit of also C# witchcraft. So you can concatenate strings with a plus, or you could put a $sign in the front, and then you can do this, and we can do this and say our dog count and our cat count, and that makes it easy to read. So we're going to say our dogs, and then cats. Okay, fantastic. And, you know, from here, it's really just determining what logic you need to get your code running. So what we're going to do is in the pet store, or in the program, and I'll show you how to get input as well. We create our pet store, and then we check our pet store. Then let us add to it. So my store.add new animal. We need to add a new cat, John. Let's add a new dog, add animal. Actually, let's add another cat. This is going to be Sarah. And let's add another cat. I don't know why it's all cats today. And, well, it's because nobody likes cats. And I'm going to get so much flack for that. Oh my goodness, this one's going to be Tiger. Okay, so we've got all of these, and the video is already 22 minutes, but we're almost done. At this point, let us check our pet store. Okay, so you see, we have 1 dog and 4 cats, and we have our cats, and they are all in their order. And there's a bunch of things that you can do to make them ordered however you need them to be ordered, do whatever you need to them. I don't care enough, and it's not part of the requirements for this, but if you want to talk about that kind of stuff, we can. Next, let's add the ability to add and remove animals. So console.readLine is what we're going to use to get input. And if you hover over it, it'll tell you that it returns a string. So we're going to say string input. And there's another thing you can do is you can say console.clear. So maybe you want to make a menu for this and have all your actions. So let's actually set that up. Let's make a void main menu. Let's make a void pet store, or yeah, and then you can handle it like a state machine, and we could do like void remove pet or whatever you really need here. Structure is up to you. It's just nice to stay organized. So we're gonna run our main menu function off the bat. So we're gonna say main menu, and we want to keep the player trapped here. So we're gonna drop in a while true. So you say stuck. While true, this is your life now. You are stuck here for all of eternity. There is no escaping. Then what we should do is let's start by console.clear, just to clear the console. We'll have all that at the end. And then let's take the input. So string input equals console.readLine. Okay, and writer, did they change how this worked? It can be null. That's new. So now what we can do is we can do a switch statement, and we can check what the input was. So case, our input, and a switch statement is really just like a series of ifs. So I'm going to write it as if statements as well, if that's interesting to you, but switch statements are more optimized, so you should use them whenever you can, especially when you're only comparing one thing. Well, really only if you're comparing one thing. So add, or maybe it's going to be buy, sell, and then exit. And we need a default, of course, because it's very easy to mess stuff up. Then what we should also do is we should cast this to upper. So we're going to say .to upper. That way our input, and let's put a thing here. That way our input is always uppercase. So this will check out properly. But really this is equivalent to writing if input is equal to by. It's exactly the same as writing that, else if the input is equal to cell, else if the input is equal to exit. It's exactly the same. There is no difference, besides for the compiler is able to optimize it. So again, use a switch statement when you can, but there is no difference in these two. I'm not going to keep this because it's gross. Okay, what we want to do is up here, console.writeLine, welcome to, and then let's actually do this so it's nice to work with. We're going to say pet store dot, whoops, what is it? What is our pet store? My store. My store dot name, or get name. Let's generate this function. So I'm heading back to the pet store. At the end, public string get name, just like we did with the other. I'm going to the top, private string name, and then as a parameter, I need a string store name, and we pass it down. So name equals store name. So you can see my mixed languages is not helping me. Anyways, return name. There we go. And now we can say welcome to my store and welcome to Gabe's shop. We might need to do a backtick here because you can't have quotes. Cool. Another thing you can do is you could also do an at in front, and that means literal. Oh, you don't need to for a single quote. That's good. Great. So we have welcome to Gabe's shop plus, and then what would you like to do? Let's do /n to make a break line. /n. Okay. We don't need another quote here. And what is the issue? The issue is we don't have the bracket here. There we go, like this. We don't need this. Pretty. There we go. Okay. So let's check it when we press play. Okay. It says our active pets and our total pets. While true, and now it's waiting for input. T. Oh, I have to press it twice. And it didn't wait, so what we should add at the end here is a console.readKey. Just a blank read key. If we hover over it, what does it say? There was a parameter. So if you hover over it, it says that the parameter, I think there was a true or false intercept. True. Which should now mean that if I write A, for whatever reason I had to press enter twice, but now if I just press another key, you'll see it clears and it resets. What would you like to do? So it keeps going back up here. So let's move input down here so it makes more sense. Let's add this console.clear as well to the very top, just so everything is working neatly. And we get our input. What would we like to do? Let's continue. Add or buy a pet. And then sell a pet or exit the store. And then in all these, we would just add our logic. So console.writeLine. We would say purchased a pet over here. Or rather, what pet would you like to purchase? And we'd handle our logic. And then over here, please enter the information for the pet you'd like to sell. And over here, we'd exit, so we would say break, which would exit us. Or actually, break's not going to work because we're in a switch statement. So let's create a boolean, bool in store equals true, while in store, and in store is false. We have exited the store. And then at the end here, console.writeLine, press anything to leave the shop. If you want to be fancy with it, another thing you can do is you can say console.foreground color equals color.red. Is a different type of color? Console color. There we go, console color.red. Also, this is why it's handy having a good IDE. And then what we need to do is we need to make sure that we reset their color. So let's make it white so it's fancy, nice and easy to read. Our instructions are boldly marked for us. Make it green. Always a good way to flex and impress your professors is to do stupid shit like this. Okay, I'm not going to do sell, I'm only going to do buy. What we're going to do is we're going to say for each, or not even. We can say pet store or my store dot check pet store, which is going to print all of our dogs. And let's just run this quickly. It's going to print all of our animals. Okay, so we have Jeff, Tim, John, Sarah, Tiger. And what I want to do is I want to buy. Oh, wait. I'm not in the right spot. Let me remove the check pet store from over here. Let's remove this input read line because it's freezing the console. That's actually why I had to press enter twice. I'm stupid. And let's remove the console.write line here. And we have this. It's our script. Okay, we'll go to Gabe's Pet Shop. What would you like to do? Let us buy a pet. I should not have pressed space here, so let's undo that. Let us buy a pet. What pet would you like to purchase? Notice it's in red. It's very clear and easy to read. It tells us our active pets. Next, let's get our input again. So string pet name. Okay, and then let us store our pet name. But before we do, let's head back to pet store and let's actually verify that both of these are lower. So we're going to say pet name here dot to lower, and then over here ID, and we're going to also set the name here to be dot to lower. ID equals ID dot to lower. Just so that way we don't have any silly typing issues. And another thing they might be thinking is, well, what if the names are the same? So maybe you want to add an ID to the names as well. You can compress it as well. You could say like John 1, or you can give them last names. It is up to you. That is up to you to decide. This is kind of just like the basics of writing a console app. So we are going to read a line here from the console, which apparently could be null. What we're going to do is we're going to say if the pet name, and then, or we don't even need to. We've already made a helper function for this. So let's put this over here. Sorry, because I messed up my configuration. And let's actually move this. And let's check a console.clear over here. Just so that way it's nice and clean. We'll get the pet's name, and then we're going to ask our shop, so my store, dot remove animal, and we're going to remove our pet name. Okay, then we need to store it. Pet, my pet. Okay, we're going to say if my pet is equal to null, if we have failed, then let's say console.writeLine. This pet does not exist. Check expression for null. Is that not what the point of that is? Whatever. Let me do this. It's always false. When we remove an animal, it's possible to return null. Why? Yeah, we had a question mark over here, just to tell the code that it's possible for it to be null. It is possible. And what we'll do is over here we'll say if ID is greater or equal to the storePets.count, then return null again, just so that way we have everything in our place ready to go. Okay. Now in here we remove our animal, my pet, store it, could be null. If our pet is null, this pet does not exist. We will break early. Otherwise, let's continue. Yeah, otherwise let's continue. So Let's fold this in. We can put a question mark here. We notice how we don't need to ask if pet name is null. That's because this is doing it for us, although it's still complaining. So if we add an exclamation mark at the end, I think I won't care. Oh man, I've never had it complain this much. So if our pet is null, then this pet does not exist. Let's leave. Otherwise, we need to remove our pet, which is already done for us. Let's tell our pet to bark. So my pet dot and let's say speak. Now speak doesn't exist yet. So what we're going to do is we're going to go in here. Let's make a function. And we want our other to be able to override it. So public abstract void speak. And there's many ways to do this. Because it's an abstract class, we can make abstract functions. An abstract function forces the other files to implement it and say what their definition is. You could also make a override function. So we can say our public virtual void speak override. And in here you can define how you want to do this. So we're going to say console.writeLine. And then we're going to say get name or name says hello, which makes no sense. And then we're going to go to cat. The cats suck, so cats aren't going to speak. They're going to say override. Notice how we say the exact same convention here. It's override again. Speak, override. And then over here, we're not going to say base.speak, because if we did, then it's still going to say whatever says hello. Maybe we will. And then we're also going to add in our console.writeLine and wags their tail. That's it. And if you want to append it onto the same line, then you could do like, or we'll just say and barks happily. I don't know, whatever, it doesn't matter. It's a stupid project. And then in here, so void speak, we want it to be different. Oh, the cat barks, whatever. The cat meows. And then the dog barks. Great. Okay, you'll see that it's purple for some reason. Adding abstract method requires it because the game is running. And then what we can do is in here, if my pet is not equal to null, then we ask our pet to speak. Let's also ask our pet to speak override, just so you can see both of them in action. Okay, buy a pet. Let's buy Horsea, which is the name of my horse in Red Dead Redemption. Pet does not exist. Press anything to leave the shop. Or rather, it should be press anything to continue, but whatever. You just change this. Let's buy a pet again. Let's buy John. John and meows happily. John says hello, and John happily barks. Now, John over here is a cat. So John will do the cat logic, which is to override speak and meow happily. And then in speak override, it's going to do the base implementation, which means it's going to go back into pet. It's going to do this. Then it's going to go back here and do this. Okay. Now let's verify this works. And let us buy a pet, and John should be gone. We have less cats, and everything is working. Hopefully with this information, you are able to complete the project that you have. I know that this video is long. The script is also available for you in the description.